And we're live. Welcome, guys, guys and girls. So this is my last stream for this year. So if there's any questions today before this year, then I'll be back probably the 9th or 10th of January online, because I'm starting to work next week again, unfortunately. So let me just open some KiCad Altium. What are we doing today? File open project. Let's wait for some viewers. Share screen. So what project we're going to work on today, guys? I'm just going to share the link to you guys. If you want to join me on stream, then you guys can have it. Hey, Akshay. Yes. I'm busy with now. I'll probably release the second part tomorrow, speaking about the components, speaking about the PCB. And then part 3 will be talking about the programming and stuff. So there's some stuff I did have to change to the PCB, but I'm making a whole just discussion, because there was some problems with the power and stuff, but we'll work through it. Do you have drones of your own? We are definitely going to do a version 2 of the drone. That's for sure. Just want to check. I just want to check. One of our community members sent us quite a nice, how can I say it, explanation of the Nixie clock. So guys, please feel free to join me live on stream if you have any questions. I'm here to help, not to do my own project. I'll do it on the side anyway. Just send the link to you guys. I'll send it on Discord as well. I'll just check in my. There we go. I just want to. Too many. I'm checking my own videos on YouTube. Share the link on Discord. Cool beans. There we go. Boom, done. I just need to get that Discord. I want to just check. Someone sent me a share. Hey, Kamikaze. I was actually just forwarding your Hackaday to Kerry because I've got Kerry's Discord on the PC and my Discord on the phone. You want to go over that IC you wanted to do? I'm trying to sort my life out here. Hey, Krish is here. Hey, how's it going?
Hey, bro. So Vansh and I were talking after you left. So,
Yes.
So actually, Jay, Vansh are now officially doing some project.
Oh, nice.
All thanks to your server.
No, it's fine. That's awesome. I thought it will happen. There's so many people with ideas on the Discord channel that sooner or later people team together and do something. That's awesome.
Yeah, bro. Wait. So we were continue. Shall we continue with that?
Your
thing?
drone.
Yeah.
So you don't assume or what?
So I have downloaded that file, but I don't know how to like import and stuff. 1 second, I will.
Share your screen.
Yeah. 1 sec. I think it's visible.
Yeah, I'll add it. Cool.
Yeah, so I have to just open this. So what I have to extract from here exactly?
What did you do? You tried to download a footprint.
Right.
Did you read the how to import file?
Which one? This?
The
Oh, this
last
one.
one is. That should explain it.
Okay, let's see. Oh, so this is a guide. I hate guides.
What? How are you gonna learn, man?
I just wanted to be, quick.
Be told.
No, be told and be quick. Wait.
Yeah, one thing about PCB design is you're never gonna be quick, eh? This is a lot of work.
Okay.
You must be ready for that. Kamikaze, we'll test it after I'm done with Jay. We'll make that component.
Wait.
Okay, so you want to import a footprint?
Yeah. I'm
Should
just
KiCad.
extracting on my, yeah. I'm
Yeah,
just I just extracted it. So yeah. So this is my schematic. How do I do? I'm a
uh,
total noob.
yes,
I'm a
yes,
total
yes, yes.
noob.
Let's see. So you've got a library, right? Thinking about the easy ways to explain to you. When you go to your schematic, on
Hmm.
the top left, you'll see tools. I'm just waiting for mine to open up. And there should be like library management. What's going on here?
Hmm. Um.
I'll check now.
Symbol library editor and assign
Pre-
footprint.
Preferences. Preferences.
Okay. Preferences.
Manage symbol libraries.
Yeah.
And then there you should be able to add it. But I've never done snap EDA. So let's just open that read thing and just see what they say. So here is where you import the library. So did you download a .lib file or not? Just check in that
Okay.
folder. Did you download a .lib file in the folder you
Wait.
just downloaded?
So yeah. So there was one lib file. Yeah. This one. Uh, yeah. This one. Oh.
No, no, you can't open it like that. Okay, so if you go to where you were now, symbol libraries,
Yeah.
and now at yeah, and now at the bottom you can so global libraries on the top left.
Uh-huh.
Yes, and now you can push the open the folder. No, 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 no. Okay, push the folder now.
Yeah.
Yes,
Okay.
and I'll
This
go
one.
to that lib file.
Hmm.
Let's see what happens.
Yeah.
Okay, push OK, and now you should be able to push A,
Uh, okay. So it's like
and now search for ESP.
yeah.
There it
This one.
is.
Huh?
Yes, there we go. And there it is. So now you need but if you double click on it, so you're going to
Double
push it.
click.
You have to push escape first. So you always have to exit. Otherwise, you're going to place again.
Oh. Okay. And then double click.
Yes. And now you can see is there a footprint? I don't think there are footprints. So you can see in the footprint line, it says module no top, third one.
Wait. Where is footprint? Oh yeah.
Yes. So that's, no, you don't click show. So it's linked to a footprint, but I don't think you've installed the footprint yet. So you have to go back again to preferences.
Okay.
No, but now you have to be on the PCB side. So this is the
Okay.
symbol, and your PCB is the
Ah.
footprint
Okay. So I have to go to the PCB side of one side.
of the project. Yeah,
Um.
yeah.
This one. No?
Go there, preferences, or you can do it. You can do it in this main project. Go to preferences.
Oh. Oh. Acha.
It doesn't matter. Now you have the PCB. You can do either or. Preferences,
No. Okay. And
manage footprint libraries, and now you add it the same way. So the folder at the bottom,
yeah.
and then go to
Okay.
your.
Desktop. Mm, wait. It's not here.
Yeah, what? Just look at what. So you're looking for a plib tab. Did you download something like that?
No, I downloaded Footprint plus the one
Symbol.
second. Where is that?
Just
Yeah,
go to the folder.
1 second. So I downloaded this symbol and footprint both. So I came here and which file? Dot step and this is I don't know.
Just see the property, or just open the window so you see the full name.
Um,
Just open the no. Just open the. Yeah,
so it's a
that's the footprint.
this is
So it's
a
a
okay.
no. Where you were was a footprint.
Okay, this one.
Yeah, it's a footprint, but it's a file extension mod something.
So I will redo this.
So
Extract.
okay, so you haven't put it there yet. Oh, it is there.
It is there, yeah.
KiCad mod, I think Snap EDA has a special way of doing it. Like I said, I don't really use them
But why is it in showing up here?
because it's looking for, if you close this window,
Yeah.
it's looking for pretty. You see all those file extensions are dot pretty, pretty, pretty.
Mm, one sec. No. So this is the file that I'm looking for. .keycad.
Yes,
This
yes,
one.
but
.keycad.
Snap EDA has a special way of importing it. So I never used Snap EDA. So let's just go to the how to import and we can read there because they explain it. So
Okay, so
you had to
how?
open the import guide, top right.
Yeah.
There we go. And what do they say about go down?
Double click. Uh, okay, so we can see the video as well.
Just control F keycad. Well, I
Control
don't know what
F.
Linux is.
No, it is. Oh, it is some finding something in the page.
See, now
Control
this is
F.
for Altium, but you need it for KiCad.
No, I got. Oh, this is for
No,
Altium.
but go down. So it will probably be different sections. So we'll have an Altium section, we'll have a Kick Eagle section.
So yeah, Eagle.
Yes, so
KiCad
there we go. So they will explain to you how to do it.
to edit
Yes,
schematic symbols. Then we went here, we did this.
yes.
So we port
Others,
footprints. Yeah, tools, edit PCB footprints,
yes.
manage footprint libraries. Yeah. So we were
We're right.
doing, yeah, so where tools, footprints, preferences, libraries, tools,
Hey, Maverick.
no.
What did it say? You must read.
Edit PCB footprints. There's nothing like that.
It'll be on the main side.
One. In KiCad, go to tools and then edit PCB
Yeah,
footprints.
in your
So,
main
so
window, not your PCB window, not your schematic window,
oh,
your main window.
oh, main window. Okay, this one. Okay, so
Edit PCB footprint. There's it.
hmm.
There's it. Yes, there you go.
Control F. This was the thing you're talking about.
So what do you have now about the drone?
What do I have up? So the
You've got
parts.
the ESP.
Yeah,
You've
I've got
got
the ESP, the motors, the frame, the batteries, and pretty much everything.
So you just need a
Just
controller.
yeah. So no, not the control. I just need the PCB, the
Yeah, but what's going to
brains of
control
the.
it? Yeah, but are you going to use ECS for controlling it, or what's your plan?
So to control the drone, right? So
Control the
I'm
motors.
thinking. Oh, to control the motors. I mean, someone was saying about this diode or something.
Diode, a
No,
MOSFET.
no. MOSFET. Sorry,
Yeah,
MOSFET.
that's what we did with our little drone. So we used the MOSFET to
Ah,
PWM and switch it on.
yeah, yeah.
Okay.
So, I can't fit. That. What do you call? I was doing this project 4 months back, and I forgot all the parts of a drone. How silly of me.
Okay, let's make a nice let's say a ESP piggyback board with MOSFET motor control.
Yeah. So that's So pretty much like yours. Copy.
Yes, but mine is having some issues that I need to solve. So you don't want like mine.
Okay. So this is a footprint editor.
And what did it say there?
Okay.
I see.
Click on preferences and manage footprint libraries. Okay. And then that file option. Uh, where is that file? Where is it? One second. In the global libraries tab, click on existing library to table. I think nothing. Should I mean, restart this keycard thing? I think then it might work.
You can try.
Yeah.
So what does it say there? What does it say exactly on the snap PDA? Just save,
Yeah.
save,
So,
save, 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 save.
yeah. So, keycat.
It would have been quicker if we made our own footprint.
Really?
Yes.
Okay. Now, no, wait. Let's do what I was doing. Uh,
I think the footprint would have taken you 10 minutes, 15 minutes.
desktop. It's still not here.
So let's
It's
just go
still
back
not.
to and read carefully what they say.
Yeah. So, back to the schematic.
No, back to the where they explain how to import it.
Huh?
So it says, okay, you went into tools, you did that. You preference, you manage group library. Add existing library to table, the small folder, that was it.
Yeah. So we are trying to do that, but wait. I will. 1 second. I will do this small thing. Then take this file into this folder. Yes.
Okay, that's
Okay. So
fine.
it. Yeah. Then I go back here. Preferences. Symbol library.
Yeah, this is symbol, right? Not the we want the
Oh,
footprint.
oh, yeah, yeah. Sorry. Wrong thing. Preferences. Footprint.
And now you're not in global, you're in project specific. So they said go to the
Oh,
global.
that's what the thing. Oh, okay. Okay. No, it shows one thing. Oh, this is
You're in the
wrong.
desktop.
No, desktop. Yeah. Keycat.
Just click on the folder and push OK.
Wait.
Why are you renaming it?
No,
Push OK.
okay.
Push OK.
Is that going to work?
I don't know. Go to the PCB now and see if it's in library.
And then you go preferences or tools.
Just push O for placing component in the PCB.
Okay, so there was A and here it is O.
Yes, exactly. A in the schematic and O in the PCB. I don't know why. They just did it like that.
O is not working. Is there
Really?
anything? No. O is not working.
What is push escape? What and push O? And now click.
Yeah, so I'm clicking O.
Oh, there, man.
Okay. Acha. Mm-hmm.
Yeah, it takes a bit long. So why are you using Linux and not Windows?
Windows is very slow, crappy, and very buggy, to be precise. I mean, if I want a OS, I will go to Mac OS after this.
Apple.
Yeah. I'm fed up of the Windows.
I don't know, but
Ecosystem.
my footprint doesn't take this long in Windows.
I don't know. I mean, I think this is doing since it is doing for the first time.
Yeah, it takes a bit longer.
Yeah.
Yeah, Sears says Windows 10 is much better than Windows 8.
Yeah, so that's true. I mean, Windows 8 was all blocky kind of stuff, blocks here and there. Windows 10 is more like Windows 7 but upgraded.
Yeah. Uh, Ranesh, you can join, and then I'll just yeah, I will. What do you call it?
Okay, so I think this was we were looking for, right?
There we go. There it
Yeah.
is.
Okay, so I can place it.
Yeah, you don't need to place it now because you first do the schematic and then you do the PCB. Schematic's always
Okay.
first. Ranesh, you can join, and I will multitask.
Okay, so I go back to the schematic, right? Uh-huh.
Yes.
So here
Okay.
it is.
Great. So just put it nicely in the middle, so we can
Okay.
work with it.
Uh, eh, okay. Oh, so this moves with the mouse, not with the pointer. Okay. In the middle.
Yeah,
Right.
because now we're going to start. So just so to be clear, this is a dev board, eh? So all the
Hmm.
decoupling capacitors, all the power regulators, all that stuff's already on the board. So
Right,
you don't
right.
need to do all that stuff.
Mm-hmm.
So what we need is 4 lines for your motors, right?
Mm-hmm.
You need to
Right, right.
power it. How are you going to power it?
The ESP.
Yes.
So
Your ESP, is it the one with the battery or one without the battery?
no, it is without the battery connector, but it can be used with that micro USB cable.
Yes, yes.
So
You can't
I
fly with.
think there is a V input pin as well
Yes,
here, if
yes,
I'm
yes. But
not wrong.
you cannot fly with a USB plugged in.
Uh, I mean, what did you say? I mean, no.
You,
See, there is this
yeah.
external 5-volt pin here.
Yes. So how are you gonna power your module while it's flying?
While it's flying
Yes.
through the this pin, external 5-volt.
We just have to be careful because then we have to make a place for 5 volt because your battery is 3.7 volts, right?
Right. Yeah.
So your module does not have a place to plug in a battery,
Yeah.
doesn't it? Yes or no?
So no, there
Okay.
is no battery connector. There
Okay.
is one ESP32 other version which has a
Yes, 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 yes.
designated place for connector battery. For
Okay.
there is battery connector.
Okay. So I'm I'm not too sure, but I think we can plug 3.7 volts into the external 5 volts. We'll have to check the data sheet. Just zoom up. I just want to see all the pins.
One
So
second. Yeah.
yeah, so we've got 3 volts on top and able. Okay, so we need 4 IO pins for PWM because we have 4 motors with a Mosfet.
Hmm. Yeah.
And okay, so which one are we going to choose?
Should I look back to the diagram and check which are the PWMs?
Yes.
Or are all PWMs? I don't think so.
I'm not entirely sure. So I would maybe just go on Google, type in ESP32 pinout, and
Yep.
it gives you a nice layout of what the pins can do. I think most of them are PWM. Yeah, so you can just click on a picture there. It's quite nice.
Hmm. Yeah, the illustrators give it really well.
Yeah. So there, you
Yeah.
can see. So that's the one you have, right, with the 2 buttons at the bottom.
Right, right. Yeah, this is the one.
Yeah. Serge says it has to take 4.5 to 5.5 max.
Okay. No. This
Not
image
that
is
one. Yeah, Serge,
no.
is the 3.3 volts only an output, or can you put 3.3 volts in there?
You have a V in here and you have a ground here and
Yes.
then
Yes.
you have a 3v3 here.
Yeah, but now we need to look at the ESP. You need to look at the data sheet for this. So what can
Okay.
V in be? Because V in cannot, apparently minimum is 4.5, and then that won't work for you. So look for the ESP32. or not for the ESP32. You'll need this module. So your module you have, you'll need its data sheet. Because inside here, they've got a voltage regulator. They've got all the stuff on the board. Are you with me? No, it should not. You twice.
Yeah, so what happened? No, I'm twice. No.
Yes.
Okay. No, actually, okay. Hey, what happened was Firefox crashed.
Okay.
So I needed to restart.
Chris, just have a look for your data sheets along for that ESP, and then we can have a further look. I'm
I
just going
think
to...
people are commenting as well for this the
What?
pinout stuff. I mean, just check the chat. I was
Yeah,
having
yeah,
that.
yeah. That's why, yeah, share this. I'm gonna bring Ranesh on stream as well. You don't have to go anywhere, so I can just help him. So I'll try multitask, see how it goes.
Yeah.
There, so. Hey, 5023. Hey, Ranesh, how's it going?
You can hear me, right?
Yes, I can hear you. How can I help you?
Okay, Krish, what is going on? Like,
Sorry?
what is
We are
going on?
making that drone PCB that we were discussing.
So where you having the problem?
There's no problem. I'm just starting out.
No, he needs to supply the ESP32 with something, and he's only got a 3.7 volt input.
So what's your input voltage for that?
Probably 4.5 to 5 volts to 5.5, but he needs a data sheet to check. I'm not 100% sure.
Okay, I'll just share my screen, right? Okay.
Yes,
I need
that's
some.
it. Okay.
What I'm trying to do is import libraries. Okay. So.
Okay.
So there are already libraries available online, but I'm not able to import them to the Altium's library.
Okay.
And that's the only thing where I'm getting stuck.
Why don't you just make your own footprint?
It will see 40 it's not an LQFE. It's a UQFN package, and it has 48 pins. So it will take quite a bit of time to make that. So, and I need to and it will take, and I need to order the PCBs in 1 or 2 days. So I need it.
What footprint is it?
What
footprint is it?
It's a UQFN 48.
Okay, you can share your screen, but Altium has a wizard, right? So
hold on. I like Altium because it has the 3D view feature, and I can see the PCB, how does it look, and
yeah, I love Altium.
Keep it in an enclosure, or I need to put a heatsink on it. So that is the best scenario for that application.
Yeah, but let's have a look, because I know Altium can do a footprint wizard. Yeah, Yasir agrees with me. They've got like a IEEE footprint wizard to do it correctly. But let's do the import, because there might be another day when you need to import something strange.
No, the footprint is fine. I went to DigiKey, and they have you must have heard of Ultra Library and Snap EDA.
Yeah, Snap EDA. That's that for with Krish.
Yeah. So I'm getting the footprints from there, and it also has the 3D files. I was able to get the footprints installed in the library, but I am not able to get the step 3D packages aligned with the footprints.
Okay, so you have the footprint on. You've done the library. You just can't get the step file.
Yeah. And I basically but I'm still confused how to get everything installed properly, because for a footprint to install get installed, I'm taking 15 to 20 minutes just for one footprint.
Yes. Okay, but open your Altium and we can go through it.
There are just too many options in this. So yeah.
See, Vanch is chatting.
See, this is my capacitor. I was trying to import this capacitor. Okay.
I'll be with you, but you must open keycode.
This is the capacitor. Okay, hold on. Where is the PCB?
JP, I found the data sheet for ESP32D, but not for the dev kit.
Okay, we can have a look at that. Okay, we'll have a look.
Hey, JP, why isn't the PCB library open?
I can't see your screen, eh?
It's too small. Okay, yeah, fine.
I think you're sharing the application, not your screen. Or...
I have shared my screen.
Yeah, but I'm seeing your Discord. I'm not seeing Altium.
Oh, hold on. Screen. Hold on, just a second.
There we go. Okay.
This is the PCB?
Yeah, it's a capacitor, yes?
That's a capacitor only. This is one of the issues I'm having. Okay, so I need to place the 3D body. Okay, so I place the 3D body.
Yes.
I choose this one.
Is that capacitor?
Yeah. Where is the view? I'm done with this now. I'll just save it, and I try to. I need to align this one. Do you see what is the problem?
Yes. I'll go back to where you were.
Yeah.
So at the bottom, you should have, on what layer did you put your 3D? On mechanical 5 or what layer?
It's mechanical 1.
So if you click on the part, it's a bit strange because your mechanical 1 layer is like full on purple. You need to see like one with a mesh. Just click there in the middle and see if you can find it.
This one?
I think so.
Yeah.
Just move it up so we can get a reference for it. Is that it? Just let go?
Yeah. This is the 3D body.
So at the bottom, so if you go to 3D view now, just to see it. And then on the properties, you'll start moving it. So just push 3.
Okay. Yeah. Do you want me to press 3?
Yeah, push 3. I just want to see how it looks.
Okay. I did it.
Well, I don't see anything. I think you have to click off the component. So you mustn't have anything highlighted.
Okay.
No, just push away. Don't highlight the component.
Yeah, I didn't get it.
Just push escape. Push escape.
Okay.
And now click away, or is it still highlighted? Just click anyway.
Yeah, I've clicked.
Okay, now push 3. You must be able to go to 3D.
No.
What number 3 are you pushing?
Number 3.
Yeah, which one? On the right hand side or padlock or the top?
Left hand side one.
Okay, how did you get to 3D previously?
What?
You were 3D like 10 minutes ago.
Okay, fine.
Okay, there we go. So yeah, you need to delete the other one. So you've got, what is that gray box?
What
is that gray box?
I don't know.
You need to delete that. So go back to your 2D.
Okay. Just a second. How do I go back?
Not 2. So 2 and 3.
Okay. Now I'm getting it. Now I'm getting it.
So just, I don't know why. Did you make this footprint?
No.
Just that pink mechanical. That's a lot, man. Just delete that. On the left hand side.
What do I do?
Just click on there. Click.
Which one? What is it?
Just click on that pink spot.
Okay.
Just move it. Just move that whole pink block away. Yeah, there we go. There's your brown thing. But just move that away. Yeah, okay. And then you can see
that.
Yeah, there's 3D there. delete it.
I'm deleting it, right?
Yes. So now you can actually see that your middle point is that X with the circle around it.
Yeah.
So if you go to your component, to the component on the right-hand side, sorry, component on the right-hand side, yeah. So open properties.
Just a second.
So if the component center point is in the center, you can just make the location 0, 0. If it's not, we have to do something else.
Okay, it's taking some time.
You need to click on the component.
Just a second.
And now properties, there we go. So on top, you see location.
Where is it?
Right on top, location.
Yeah.
Make it 0, 0, see what happens.
It is X and Y only.
Just make it 0, 0.
Okay.
Because I'm assuming someone would, there we go. I don't know if it's, okay, you see it's offset a bit. So now what you can do is, there's different ways. So you can see the point is on the edge of the board. So if you've got the height of the board, you take the half of the height and that will be your center point.
GP,
Yes.
I will have my dinner and I will come back in like 15 minutes.
No problem. I'll wait for you, Krish. Thanks.
Okay. So you can put me off the stream, but I will remain on StreamYard.
Yes. I'll say remove.
Okay.
Thanks, man, Krish.
Yeah, what we are saying?
So there's different ways we can do this. So you can see where the middle point is on the edge of it. So to get to the middle point of our component, we have to move down by half the width of the component. You understand what I'm trying to say?
Okay.
So
So
we can go to reports. Go to reports.
Go to where?
Reports top left next to tools. Reports, sorry. Next to tools. Next to tools. There we go. Measure distance. And now just measure the height. Now of your component. Your thickness.
This one.
Of your component you want to move. It's not snapping because, push escape, like clear everything. Just push escape.
Yeah.
No, escape. You don't want stuff highlighted like this. So when you do something, you want it clean. So just click away. Just click anywhere but on a component. Yeah, you want it like this. So on this right-hand side, go properties. And now you can see, why is there no snap? Let me make this bigger. Snap options, your second one. Yeah, that one. The second white line, there we go. So you can see it will snap only on current layer. So are you sure that is your mechanical 1 or mechanical 5? Your component, so your component, click on your component. So properties, you can just push the pin on top to keep it open. So it's mechanical 1, it's fine. Okay, great. Yes. And now go reports measure. But sorry, just go back to properties where the snap is because you want to snap to the edges. So let's just make sure we can snap. Click away, clear everything. So when you're starting, so you can see all the stuff you will snap. So you'll track arcs, intersection, pad. So you can just snap to everything. You can put everything on.
What?
On the left side, you see on and off.
Yeah.
Sorry, where you were? Objects of snapping. So objects of snapping.
Where?
On the right-hand side, you were there. There. So there's on and off. Down.
This one.
Oh no, current layer. Go back. And then the tick boxes. Just click on. Just make all the tick boxes yes.
Okay. I need to do it now.
Go to reports, measure, and now you should be able to click to the sides. How big is your grid? Now try to get to Yeah,
Okay,
there we go.
there.
Perfect. That's perfect. Go down. Click on it. Go down. Click on it. So that's
It is
0.55. So it must be what, 0.275?
0.55 mm.
So it's, you need half of that, so it's 0.275, I think.
Yeah.
Okay, cool. So go back. Okay. And now click on your component. And now on the right hand side, do you want to work in mils or millimeters?
I'm fine with anything.
Okay, clear everything again and click on the background. Push Q. There we go. Now we're millimeters. You'll see at the bottom left where it says grid, it changes.
Yeah.
So let's go millimeters because there we go. Keep it. And now click on your component again.
Yeah, it's me.
Click on your component again. And then you can make the go on top, on top, on top.
Okay, so on rotation. Okay, this is rotation.
No, not rotation, the position. So your Y you can make minus 0.275. Your Y, your X, not rotation, not rotation.
Minus 8.
No, this is rotation, right? We just want to move it down. So not there. Make that 0.
Okay.
On top, your location, your X and Y location. Right on top. There we go. Yeah, but you're not 0 on the thing. So we need to move Y down. So we go minus 0.275.
Okay.
0.275. 0.
275, right?
No, 0.275.
0.275.
Minus 0.2. You want to move it down. So positive is up, negative is down. Yes. So you understand why we're going down half. There we go, in the middle.
Yeah. So it's in the middle now.
Now you can lock it if you want.
So basically, I feel like Altium has like many things, and that is making it complicated. But it is like once you understand this, it will be like way easier to make the PCB.
It's much
you can
quicker.
play around with many things.
But what was your question about the other one?
So let's just get over this one first, then.
Okay. That's fine, right?
This is the problem.
No. Yeah, now increase. So you got X and Y, and then Z is up.
Yeah,
so
Z is up.
We need to increase the Z by half the height of your component.
Yeah, it looks like it doesn't look like it's half.
Okay, but now you can play with your eye. You can make it like just 0.1, 0.2, 0.3 until you're happy with it.
So how do we do that?
It's exactly the same way you did it earlier. So go back to your component.
Okay.
Push 2. Click on it again. And now there should be a standoff height. Just underneath rotation Z, there's a standoff height.
Yeah.
So that is the height that will be lifted.
We can start with 0.01.
No, might not be enough. Do a 1. Do a 1. Go big. 0.1 is nothing, eh? But yeah, we can see what it does.
Okay, so just
and now you have to push 3.
Yeah. Okay, that's good.
You might have been right, man. Let's go 0.1. But you see, so it increased the height.
Okay. That is little bit. Okay, let's do 0.25. That looks fine for me. There is still some gap.
Yeah, then you can just make it down.
But this is like not that important. This is just for looks, right?
It can be important when you start making a bit more complex stuff, because then when you have daughter boards on top of each other, then the height's important, what you can put on top of each other. And if it has to go into a housing, the housing needs to be a certain size. So then it's important. But you'll always have tolerances So rather be safe than sorry.
Okay, it's done now. Can I log this one too?
Sorry?
Can I log this one too?
Log it? What do you mean? Lock it? Yes, you must lock it.
Okay, I don't see where I
Oh,
can
no,
lock
no,
it.
no. Oh. No, because once you're in the 2D view, you cannot move it in the Z height.
Okay. Oh,
You can
yeah,
only-
yeah, yeah.
No, no, what are you doing? Don't rotate it.
Oh, just a second. No. Yeah.
So that's why you only want to lock stuff when you start doing it. So yeah, that's fine. So once you go in 2D, you won't be able to move it again.
Okay.
Yeah. So like Yasir said, it's important when you make casing, then the height is very important.
Yeah. Okay, so I'll just save this one now. This one is done. Okay, so where's so suppose like just get a random library, or just get a random library for me. Which one should we get?
What exactly do you want to do?
I'm making the ESC.
Yes, okay, but what so firstly, what chip do you want?
XT spin 32F0A.
Is there a reason you want to make the footprint yourself and not just get it from the library?
Yeah,
Why?
just like I need to order the PCBs in
Yeah,
a day or two.
but where's your schematic? So if you open a schematic,
We already have a reference design.
yeah, but you haven't made an LTM yet,
Yeah,
have you?
no, I haven't
Okay.
met, but because
So
I need to.
just open a brand new sheet. We're not going to do this. I just want to show you.
So I'm just closing the projects right now. Okay.
Yeah, just file new schematic.
Yeah. My parents are also here now.
Oh, hello.
Do you want to meet them?
Sorry?
My parents are also here now. Do you want to meet them?
Oh, yeah, if you want to. Hey, how's it going? Do you have a big screen there or what?
Yeah.
It
So
looks like
basically, like attached camera either. So basically, what I have done, like, okay, just a second, I'll just show you the setup. So this is my laptop. There's the
That's nice.
Yeah, so it helps when I'm working.
So just open a schematic because
Yeah.
LTM is quite cool. They've got a massive library online, so you don't actually have to ever make your own footprints. You can save a lot of time.
I'll just make a different library. It just close.
Did it crash?
What version of Altium we are using right now?
Sorry?
What version of Altium are you using now?
I think 20, but there once an update now, but Kerry's computer doesn't have space, so I need to delete some stuff or move it. So the new one's 20.2.6 or something. No, I'm lying.
Mine one is 20.2 something.
So the new one's 21.08.
Oh yeah. Okay. Yeah. But like I see that this is very slow. Even on my computer, it's really slow.
Yes, Sarah wants me to look at the Discord channel. Yes, the latest. I must update mine. I'm in the general channel. What are we looking for? Can you share your Streamlabs audio settings? I don't use Streamlabs.
Yeah, I have loaded the schematic sheet and the PCB doc.
Yeah, you must just show. You're not showing on the stream.
Just a second. Okay, my Discord is again here. Just yeah. I made a new project and both of them are new, fresh one. So we'll start from here. Go ahead.
Okay, so if you go PP place components,
What?
push PP.
PP.
Yes, PP. I don't know how to. Someone wants me to become famous and buy followers. There you can type in the component you want. No, don't worry about that. No, don't worry about it. Don't worry about it. Just type in the component you want.
Okay.
In search, just type. No. What you doing?
What did you say?
PP. Just type. In search. Just type. Just type the component you want.
That it's not there.
Ah, it is. I'll show you. Now go manufacturing search, part search. At the bottom. Yes.
Okay, yeah, it is there.
No, but just be careful. Just be careful because you'll see on the right hand side, it needs a symbol to have its footprint. So the data sheet might be there, but the footprint might not. So go down. The footprint's not there.
Model. There is no model.
Right, so just scroll down and see if you can see one with the footprint. You'll see a specific symbol. No, the manufacturing part. There, just scroll down. No. Yeah, so they don't have any footprints for it.
No, doesn't look like it.
You need to have signed in. But you are signed in, right? You are signed into Altium?
No.
Okay.
This is a crack account. This is the like crack version of it.
Oh, I should not help you with crack stuff.
Yeah.
Yes, just type in ESP32.
What?
Type in ESP32. I just want to show you how it looks when there's a component. So you see that green little thing?
Yeah.
That means there's a footprint.
Okay.
Okay, so let's go back to your, yeah, so there's nothing.
Yeah, there's nothing. So
Okay, back to what you wanted to do. So you started from Snap EDA, right?
yeah.
So you've created a schematic library.
Yeah.
Where's your schematic library?
Wait. Do you want me to open a new schematic library? I haven't opened. Yeah.
And now if you go to Snap EDA, they will actually tell you how to do it. Just import. Just go to Snap EDA website. You download from Snap EDA, right?
Yeah. Yeah.
So which one did you use?
I F0A, this one.
But you see, so that package is a generic package, right?
Yeah.
So Altium has a footprint wizard.
Okay.
So if you go, just trying to file new library, PCB library. Let's just see. But download it so long. Click on it so long. So we're gonna have two different ways. There's many. So just click on the one you downloaded it. Hey, Krish.
Hi.
At the bottom,
I
it
was,
should-
Not available.
I was just texting you.
Oh,
I was waiting. That's why.
I can see at the bottom. So at the bottom, they should tell you how to import it.
Yeah, we were discussing about the IO pins.
Yes.
Which to use.
I'm just helping Ranesh quickly.
Yeah.
Okay, both of them doesn't have a symbol. I need to get somewhere else. Wait a second. There's another.
There's a place here, see it also recommended. Component search engine.
Component search engine. I use this one too.
But if you go to your
Yeah, this one. We need to modify this part. Like we can modify this one.
go down quickly.
So you can see the EP pad, right? The EP pad is just too big. It is 2.2 mm. It is 2.8 mm, but someone has like made it wrong. We will manually do it.
No, but you go to Altium again.
Yeah.
So if you go to tools and you see there's okay, there's symbol wizard, you can use that. So there you can choose how many pins. So that will do it quickly for you.
Do I need to count the EP pad too?
Do you want to connect ground to it?
Yeah.
Yes, then you have to. And then you can see in line what you want to choose. Do you want to choose a quad side or whatever? And then you can see.
Yeah.
And then you can give it names and everything.
Okay, so it is like okay, so I will just name it.
Yeah, but okay, so just push OK, because I'm going to show you the PCB side and then it's done. You can do this later, the naming and stuff like that.
Yeah, we can name it later. But
yes. So just say place.
Okay. Place symbol.
Yasir, what do you mean? Can you go on this again? How we did this?
Okay, let's do it again then.
Just go again. Just close it.
So for this, wait, why does it close? Just close the project.
Why you close it?
Vacuum is just running too slow on my laptop. Just running too slow. I have an SSD, like then also is that it's running just super slow.
Yeah, well, Krish, have you got the data sheet yet? Are you with us?
Yeah. I have got the data sheet.
Of the module.
Yeah.
So
not of the dev kit, but of the ESP32D which I'm using.
I know the data sheet of the ESP. It's 3v3 voltage input, but the dev kit has a different one. So I'm just going to quickly look if I can find the dev kit.
Okay. Acha, I had one question. What do you mean by type? So here it is type P, type I, and then type IO. So IO is input output. I know. I think
Passive,
P is
passive, I think.
uh, passive. Okay. I was thinking it to be
Oh,
PWM.
power.
Can
Don't
you
know.
share the screen? We can tell you from there.
Oh, okay. One sec.
I'm I'm
Just
stopping the.
no. Just finish this part because Yasir wants to see it. So while you're busy with,
Okay.
so go to tools. No, you were at the library, right? Schematic library.
Yeah. So it is very similar to adding a PCB or a schematic. You just click on the schematic library. One
Yeah.
tab will open here, and then you just go there, and you go to tools, then symbol wizard,
Yeah, that's fine.
and then you can enter like how many pins you want and what kind of package it is. It is like some general package. Then you can just place it from there. You can just choose it from here, or like if you want your own custom package, you can choose this one and you can manually make the system.
Yours is generic.
Yeah.
So choose the quad.
Okay.
Yeah, I mean you
I
can
needed
just
49 pins, so I just choose 49 pins.
yeah. Okay.
And make it for me, and then I will just place the symbol.
That looks nicer. But you can change the names and stuff later. Now go to the PCB library,
Okay.
and now you do the same tools. Oh,
Just a
you
second.
know, yeah, you don't
Need
know.
to open the library also. PCB library.
And now you
Yeah.
go tools.
The library is open now.
Mm-hmm.
Then again go to tools and like
IPC component wizard. Yeah.
IPC component.
Yes.
Footprint wizard.
Yes. And now you can go next. And now you'll be able to choose your QP.
Wizard PCB also. we need we need PQFP. LG. Okay, we need a PFQN. Oh, this is PFQN.
Is it not similar? What's the difference?
Like no, it is not similar, but the name is different.
Yeah.
But
Doesn't
the
matter.
name
You can alter the width and the pitch and everything. So go next.
I don't know this one. No, this is QFN. I needed this one.
Okay, go
QFN.
next. And there you can go. So
Okay, now I need to I
look
need
at
to
the
open the
data
data
sheet.
sheet and check its now from here I can continue. Okay,
Yes, yes,
just
yes.
take this one, just take this one and just let's go ahead. Okay, this one also I can do that.
Yeah, but somewhere you're going to say have to say 49 pins, eh? At the bottom, I think, number of pins.
No, I'm just doing this for like
Okay,
I
okay.
can change this later. I can change this later. I just need to know like where to do what stuff.
Good.
Yeah.
Chris, you
So
still there? So you happy?
Yeah. I'm here.
You sleeping, Chris?
No, I was checking my phone while you guys were discussing.
okay, what is this one? Okay, so it is actually taking each and everything into account. I was making libraries in Eagle,
Yeah.
so Eagle wasn't like taking that this much of information. Like how, what is that total? All these things
So
weren't there.
IPC is a standard, right? So this will take you through the whole standard for manufacturing, all that stuff. That's why with generic pads like SOTs and stuff, don't redo it, don't download it. This is perfect. Chris, share your
Yeah.
screen. Are you happy?
Please share your screen now.
Mm-hmm. Yeah. Yeah. So this is the documentation of
That's for the ESP. So
32D. Yeah.
But you've got a module, so the module is it's got its
This
own
one.
voltage regulator and everything on it.
Uh-huh.
And you don't have the battery one. When you guys buy from Amazon, they don't give data sheets or anything.
No, I mean, I don't think in the resources area.
I'm checking just where I buy it from quickly. VN. Yeah, it seems like VN is 5 volts, not 3.3 volts.
Hey, wait, ESP32 has 5 volts input. Like,
No. So you get the ESP32, just the chip, that's 3.3. But Krish wants to take a module and just put the module on the PCB, and the module's input is 5 volts because it already has a voltage regulator on it.
But like that the voltage regulator is only rated for like 200 milliamperes and like something in that, like near to that value only.
I think 500. I'm not too sure what's on it.
Like most of the time I've seen like 200 milliamperes. Max to max it goes to 500 milliampere. If you draw much more than that, it just dies there.
Yeah, my drone is giving the problem.
What happened with that?
So what happens is that you're right. So my voltage regulator I have is a 500 milliamp. So when I put the drone too much current, it hits a brownout error. So our voltage on the 3.3 volt go too low. But it's strange because it's kind of separated, right? Because the 3.3 volts is only for the microcontroller, but the 3.7 volts is for the motors.
So what is happening is something that is called as voltage sag.
Yeah, so it's draining the capacitor.
Yeah.
Yeah.
So you need to add more capacitors on the main line.
Yes.
If you see our drones, we have somewhere like very close to 1,000. Like we minimum have 1,000 microfarad capacitors on them.
Yeah. That's all. I'm gonna have to do a version 2 because
No, so listen. Just do one thing. Take a 25 volt capacitor. That the value can be somewhere near 330 microfarads. You will be fine with it.
I'm gonna play around with it, but I'll make videos and stuff to explain. Where's Krish going now? You chased him away.
He's going to sleep now.
Yeah. So what happens is I'm trying to get that motors running, and it's 700 milliamps, which is nothing. Just dies. But then it's 2.4 amps because I've got 4 motors.
So that is like also like low.
Exactly. It wants to take off, but it doesn't because it goes to brownout. But I'll fix it.
Also.
Yes.
Those motors will take around like 5 to 6 amp like max, or it may go to 8 amps also. I haven't tried them, but they are like super current hungry.
Yeah. Cool, Krish. Let's help you.
Yeah. So.
Okay, it's fine. So the problem we have now is we have to think of a way to power your module while it's in the air.
Right.
Can we not put voltage on the 3v3?
Hey, just like let's try to solve this problem. Like first, like let's hear him what he wants to do. He just wants to put the ESP32 full module on his board, right?
On a PCB, yeah.
Yeah.
And then have Mosfet.
PCB, right.
So make a daughter PCB that he will put the ESP32 module.
But so it's basically the drone that we did. But he just wants to have a board type module he puts on top, and then it will control the motors.
Right.
So the problem is.
Basically, I don't see any problem here.
Are you going to supply voltage to the board in the air?
What?
Are you going to give the board some voltage?
He needs to.
He needs to. I know. I think you can put 3v3 on pin 1, right? Because that's the output of the.
You can also. I think I don't have a ESP32 with me.
I do. Yeah.
them because like that's why I don't have them. But let's just get the pinout of this. Can you open the pinout
Yeah.
on the left one? Yeah, the first one. For the first one, yeah. Anyone is fine.
Yeah. My internet is very crappy.
Hey, JS.
You are not. You are not the first person to have bad internet in India.
Yeah, I hear you guys are having a bit of trouble there.
We
Yeah,
have
always
4G
trouble
here.
with internet.
We have 4G here, but the speed is like somewhere between 40 kbps to 100 kbps like during the day, and
Yeah.
it goes like to 1 megabytes per second or 2 megabytes per second at night only.
What is your speed now? Your mix? Your line?
What?
What's your line speed in India?
LAN speed? So we have fibers now. Some what we call them. Some ISPs have good, like Geo is coming with his fiber. So I saw that it is giving some amazing
BSNL is there.
on the ESC board.
What's on the
Down-
ESC board? I don't know. What is it?
I can show you my ESC. I'm going to make it open source. Like,
No, it's good, man.
yeah, so I have made the schematics and I'm working on the board right now. If you want, I will show this like after
You
we
can
solve the
share on Discord now. Chris, just open this image.
Means to maximize. One
Yeah,
sec.
oh, it's fine like this. So the bottom right, you see 3v3.
Right. This one.
Yeah, so that is the output of the voltage regulator. So when we put 5 volts in, we get 3v3 volt out. So what will happen if we put 3 volts 3 in that pin?
You can also 2.3 volt there, you know that.
Yeah, because then it's on the output of the voltage regulator. But if we want to, we can just remove the voltage regulator.
See, but the problem is if we can't put a switching regulator there, we can't like put a switching regulator on that.
Yeah, but we can put it on the PCB is making.
Yeah. So what we can do is we can make a buck converter, which will take some high voltage and convert it into 5 volts. Then the 5 volt will be given to the peripherals. Then the 5 volt will go through a linear regulator. The linear regulator will give the power to the ESP32.
Yeah, but why not just take a voltage regulator? Why do you want to do a buck boost and all that stuff?
Okay, so like isn't Krish going to put like some peripherals? There's some stuff like which can power like something which needs 5 volts or something.
No, nothing will need 5 volts.
Okay, so then it's fine. Just put a linear regulator there, put some Mosfets, and they will be good.
Yeah. Well, what, Chris? Do you think you'll need 5 volts?
Sorry?
Think you'll need 5 volts?
No, I don't think so. I will. I mean, I will not be putting any camera or some sort of thing like that.
Okay. So, but I think camera can also run a 3v3. I'm not sure. But anyway, because the LiPo battery is 3.7, right?
Right. Yeah.
What kind of camera does he want to put a camera?
Camera's version 2. Let's just fly the thing.
Yeah.
It's not a good idea.
No, because we'll take the LiPo battery, which is 3.7 volts, and just a voltage regulator, make it 3.3, and then put out that pin.
Max it goes to 4.2. That's fine.
But the voltage regulator will solve that.
Yeah.
Krish, you happy?
But
Yeah.
Krish, but you need to put a LDO there, okay? Just not just any voltage regulator. Put an LDO.
Yeah. Do you know what LDO is, Krish?
No, I haven't heard. What is it?
Those are called low dropout regulators.
Okay. So what
If
does
you
that do
want-
exactly? I mean,
So like you know what is a linear regulator, right?
no, I know about regulators a bit, but not the types of regulators.
Just imagine that there is a resistor inside that chip. Okay,
Huh?
you give it 5 volts, it just wastes some energy and makes the 5 volt into 3.3 volts. But the more current you draw, the more heat it will produce. So it is not very efficient for high current users. So it's better to stick with LDOs. LDOs are little efficient than normal regulators.
Okay. Okay, got that. So I will go back to the schematic, I guess.
Yes.
Yeah. Um, yeah. So we take this. So this is a 3v3. So we are plugging the battery in this one, right? And
Yeah, but you can't
ground.
plug in the battery directly because the
Yeah.
battery is 3.7. So we need a yeah.
Yeah, keycard looks new. Like
No,
I see the UI has changed.
he's using Linux.
Okay, he's in Linux. He's in Linux. Okay, fine.
So just go to place component A.
A.
Yeah. Do
Okay.
you have a
It will
regulator in mind or not?
me.
You. It's your design.
No, I want you guys to help me on this.
Oh,
You get the one I
That's
use
good.
is you need a big one, eh? Don't use the one I use because my one's only 500 milliamps. So maybe you should look one for 1 amp.
Okay. So what should I type? Regulators.
Let's just no, you can. Stuff might pop up, but we just need a manufacturing part number.
Oh, yeah.
What's a popular regulator in the drone industry?
Okay, what kind of supply do you want? Like, what is the current requirement? What is the input voltage? What is the output voltage?
So the
You
input
need all
one,
that.
the input voltage is 3.7 to 4.2, right? Because of the battery.
Yeah.
Output we want
Yeah.
is 3.3 as maybe.
So if it doesn't need 5 volts, we can do one thing. We can put a voltage regulator which can take to like 12 volts is the standard input like all over India. So if you want, like if you put a 3 battery, 3 series battery, if you want that, you can do
No,
also.
I'm using a lipo battery that
Okay. So
I mean it's not it's a single cell battery, I think.
okay, so JP, but like there's a problem because the regulators have 4.5 to 5.5, right? Input voltage range. Then it gives 3.3.
No. You can have the one I use is 3.7, gives you 3.3.
Okay, I find then we can use that.
Will be fine if I use a single rate output power both my ESP. That might be pushing it. I don't know. Depends. The ESP also takes a lot of current with Wi-Fi. So I don't know if you're using Wi-Fi or Bluetooth.
Oh, ESP takes somewhere like below 200 milliamps.
With Wi-Fi on as well.
Yeah, with Wi-Fi as well.
Search for LD1117.
One second.
Hey, LD1,
Oh,
it's like I've heard of this one.
which one
Yeah,
you have
yeah,
got?
I don't know. I'm just
this
No,
one.
it's all the same, I guess. They're all the same.
no. So you get different ones. So you want the version 3.3, the 3.3 one at the bottom.
This
That
one.
one. Top. One above.
Okay.
There we go. So the 3.3 is for.
Okay. Oh, acha. So you have these numbers:
So
1,
that's
2, 1,
yeah.
2,
No.
2, 5, 3, 3.
Don't. Wait. No, this we need to see. You need to see the input. You want to Kamikaze has a question for you on the chat. Which app is this? The PCB or the what app? This is KiCad that. Chris
Yeah,
is-
this is KiCad. This is KiCad. Someone had a question for me.
for Hornet.
Oh, for Horn.
Kamikaze asked the question to Hornet. What was that? Is it better stick to what? Krish, go MIC.
In the search,
Yes, MIC.
MIC.
5219.
5219.
There we go. 3v3. So you look for 3.3. 3.3
Okay.
YM at the bottom. Yeah.
This one.
3.3. Yes.
Okay. So I can place it anywhere, I guess.
Yes.
Hmm.
Now open the data sheet because yeah, I need to show you how to connect it. So just go Google and search for it.
One sec. I have the data sheet of what? The regulator?
Of the regulator.
Okay.
Because you need to know why you're putting it and if we can actually use it.
So it was MIC
5219.
5219. 3v3. This one?
Yes, that one. Yeah, top one.
I guess Google is listening us. So it gave the exact.
Yeah, just open one so we can get the data sheet.
Right. This is for YM5.
Yeah, it's fine. The 3.3, it's fine.
Yeah. So you have data sheet for Atmel, for Micro.
Doesn't matter.
Okay.
What is the 1S whoop?
Do you want me to find one for him?
Yeah,
We'll
let's
just
see.
okay, just wait, just a second. I will find.
My internet.
Yeah, I normally go to like Mauser or someone and just get the data sheet there.
Just a second. I am sharing it.
Okay.
Okay, so this is the data sheet.
Yeah, so things we have to look for is what input voltage can it take, what's the current that it can supply, what's the volt drop.
Is this the one that we are looking? Yeah, I think.
No, so you just go to the first page is always good. No, it's not. No.
I don't think this is the thing that we're looking.
No, just go back and go to Mauser or Aries components or something.
Go with DigiKey or some DigiKey. You can DigiKey is more understandable.
Yes.
Components.
This one.
Yeah, I can just open anyone there.
Oh, so where you can find a data sheet for this? Yeah.
You don't need to open the data sheet. Just read it. The specs are written below. You don't need to read the data sheet for this. Just go below. Scroll down.
So the detailed description. Okay.
Just scroll down.
Okay, so voltage output is 3.3 volt, and input maximum is 12 volt.
And the range. So open the data sheet and we can see a range.
Now you need to open the data sheet because you need to know the minimum input voltage for that, because you will be running on a single cell, so you need the minimum voltage. This it needs.
Okay, so this is the
first page is normally good, or we can.
Okay.
There's nothing on the first page, I guess. You need to go to the absolute minimum and maximum ratings. Go down. There will be a heading, minimum and maximum ratings. Yeah, click on that.
This one, no? Minus 20 to 20 supply input
What?
voltage. Uh,
Yeah, okay,
oh,
but no,
okay.
operating there, 2.5 to 12.
This one, 2.5 to 12.
So it's fine.
That's fine. Yeah, you can use that.
Okay.
Hey, what is the
So,
current 500 milliamps, right?
500, yeah.
mm, yeah, so we can use this one, right?
Yeah, so look at the data sheet and then look if you can see how you're supposed to connect this.
Okay.
Above uh,
The
Krish?
diagrams, yeah.
So
Yeah.
Yeah,
all data sheets will have typical
Go,
circuit.
go,
example.
go up,
Yeah,
go up, go up.
there.
Yeah, stop here. The top right one. The top right one.
This one,
That's the yeah. The top right one.
ultra low noise regulator. So, for in what is this 2.2 UF tantalum?
This is the capacitor, tantalum capacitor. In linear regulators, you use tantalum capacitors for more like for most of the time, but you will be good with a ceramic one also. Won't
Okay,
matter that much.
okay. And
Do you understand decoupling capacitors, Krish?
I mean, I know capacitors. I mean, is this wrong that capacitors store energy for some amount and then dissipate that
Yeah,
Yeah, yeah. So
elect?
basically capacitors are small batteries which
yeah.
contain
Huh.
which store energy, but if you want but batteries cannot discharge very fast, right? But the capacitors are
Yeah.
opposite; they discharge really fast.
Okay.
So they
So,
take energy and discharge really fast.
okay. So, what was I think? I have this Bose speaker with me. So when I switch it off, it does not turn off quickly. So it takes about 2 seconds to turn off. So I
Yeah,
think capacitors play a role there.
It's a super
Maybe.
yeah,
capacitor.
yeah. So in amplifier circuits, you have a huge bank of capacitors for filtering the audio.
Okay.
That is another like a topic, the different topic we can talk
To
because I'm
Yeah,
hey, you know about mixed signal?
which signals?
Yeah, yeah, yeah. So when you are working with audio, so there I have like seen people use mixed signal, like people make mixed signal boards. So
yeah.
one side of the board deals with the digital part, and the another side of the board deals with the analog part because the audio
Analog
is
part.
mostly like analog only. So
But
that's
let's keep it simple. I know what you, and you can join the planes with the small resistors and stuff, but let's not go there now. So, Krish, so in the data sheet you can see there. So, but there's different ones. So we've got the 5-pin one, right?
Right.
So
So this, how many pins do we have here? This is five as well.
mhm.
In, out, EN, BP, and ground.
So
Uh,
EN is your enable pin, so you can actually switch it on and off. I normally just pull it high, so it's always on. Then I don't need a
okay.
microcontroller to put it on for me.
Hmm.
So that's a good place to start.
Okay, so we will put this pin to which IO. So any,
what it would
so we'll,
It doesn't go to IO. So this is only to
okay,
supply power.
JP.
okay.
Yes.
Do we need to know the maximum rating, maximum voltage for the enable pin? Because some ICs also have a maximum input voltage for the enable pin, so you need to make a voltage divider in order to achieve that voltage.
Use what do you mean to turn it on?
Yeah, yeah. So
I
like
think
in
3.7 should be fine, but we can have a look at the data sheet. Krish, go back to the data sheet.
Hmm.
Just go for the pinouts where they explain VN, EN, all that stuff. There's somewhere here.
the enable input, yeah, that one.
Where? Which one? I can't see. This
Hey,
no.
JP, I found a good one. You are like you should be using that one. It will be better. The one I'm like sending you right now. It will take from 1.5 to 5.5 and give you 1 amps up to 1 amps of current. Take that takes 3.3 out.
Where did you send it?
I'm just sending. Hold on. I haven't sent.
But where are you sending it?
Just a sec. Just write it. Okay. Just go to DigiKey. Just go to DigiKey and search this part. That is super simple to use this one. I have used this on my flight controller. It also has short circuit protection on it. So even if you short 3.3 in ground, nothing won't nothing will happen.
Krish, I'm just going to share my screen quick. You can search for this thing so long, okay?
Okay.
No, it's fine. I can control it. Boom.
Boom.
Kamikaze, the reason is because this VBAT is going to the drone motors and it's applying the regulator. So when I run that motor, it's quite high current. This capacitor is too small to keep the charge. So then this 3.3 volts goes below 2.8, 2.7 volts, and the ESP, when it goes below 2.8 volts, it goes into a brownout mode. So that's the reason. So I need to increase this, and it will also help if I've got a better voltage regulator. So I spoke to Ornette as well, and we're going to try 470 microfarad. I don't know, just try to increase this capacitor massive. But yeah, that's the only thing stopping me now. The PID is done, everything's done. But anyway,
You have done the PID.
yeah. I don't know if it's working. It's not flying though, so we don't know if the PID is correct.
It
But
just needs to level out. Other like that, you just control. It just needs to fly. It doesn't need to do anything. It just needs to.
no, it just needs to hover. If it just goes in the air without crashing, I'm happy.
Yeah.
And then I'm going to use the Blink app. So I've started.
Control it.
Yeah,
Control it.
Yeah, control the yaw and stuff. So it's going well. Just a stupid brownout. What does the enable pin on regulator do? It just switches it on and off. So you can connect a microcontroller to it, enable it, and then you'll be able to switch on the power or switch it off. That's all it does. Chris, you back on?
Oh.
Krish, yeah. So I'm Krish. Okay, what is this? Krish, search on DigiKey.
So
this is the
DigiKey. Okay.
Just forget this one now.
Okay.
So go to DigiKey, use that. You just directly give battery voltage to its enable pin.
No, I don't get you. What do I need to do?
So just open DigiKey again. Search. Go to search tab. No, not there. In DigiKey. Yeah.
So this is DigiKey.
Yes.
Yeah. If you want, I will also send you this one. Okay, I have it. Search for TLV757.
TLV757.
33. Parrot P.
Yeah.
B. R. P. No, not parrot. Like parrot, like just P. Okay. D. R.
Wait. DBVR.
Just go back. Stop it.
Just search that. Just search that. It doesn't matter.
Just search that. Sometimes communication is also a challenge, right?
SOT 23.
Every time.
Go below.
Don't take that footprint. Yeah, take this footprint.
This one now.
Above.
Oh, this one.
Above.
One above?
Any one of them. Like the above ones are the new ones. The below ones are discontinued now. They almost discontinued. Not fully discontinued, but like they will be obsolete after some months. You can use any of this, but I have them. I can send you this.
They don't have any stock.
They have a new version, above one.
They take the new one with their stock.
Yeah.
That's very important.
Like the square ones, Krish.
Which one?
Middle one. There are three
This
ones.
one.
Right? No,
One up,
This
one
one.
up.
the second one. The second one.
Oh, this one.
No, but you don't
Yeah.
want that footprint. How's Chris going to solder that?
Hey, the footprint is also there. We can import it. What's the issue?
What?
The footprint is this has the footprint also in for the
The file.
on alter or slant.
No, no, I understand, but that Chris, are you going to be okay to solder that?
Solder what? This thing.
That component?
This IC.
Not that
No,
one,
no,
other
no,
one.
no.
The other one.
Which one?
That,
The one next to it. That one, that one. No,
Which one?
there's two components. So there's that component and the one below. That one.
Yeah.
Not that
Yeah.
one. That one's easy to solder. Go up.
No. This one.
Yes, that one.
It is almost impossible. I have to use solder paste and stuff.
Yeah, that's
No,
another
I don't
thing.
have all that. I don't have that
don't-
rig with me.
so see, you don't need a solder base. I have like
Yes,
guy
Jay.
with me.
Yeah, you told me
Yeah.
of that. Yeah. Wait. I will be not able to solder this. No.
Okay, I will solder it for you. Just like if you, like, I have the ones which are like below. I have that one, so I will just send you. Just take the
You have
below
these?
ones. Yeah, I have these ones.
Okay.
I'll be ordering the above ones in like in a day or two.
Okay, then Chris, yeah, just open and get the data sheet and then we open it.
Yeah.
Okay.
Just get
So
to the
I will get the data sheet for this one.
Yes, just click on it, yeah.
we are stuck with like at this place for a like minute or 10.
But Chris, are you going to populate this board?
Sorry, are you gonna?
How are you going to put the components on the board?
This board.
No, I mean, no. Yeah. Wait.
You-
I am
you-
going
no,
to
you
put
start-
this on the PCB.
Yes, so you sound a bit worried to solder this on the PCB. So how are you getting the components on the PCB?
I'm giving it to a manufacturer.
To put the components on?
Yeah, he told me he will put the components on as well.
Okay. Which manufacturer?
Nice.
So I have his number, but I don't remember the company. So
But he's going to charge you
he's in
for it.
India. Yeah,
Hey,
he's
how
gonna
much is-
charge him.
Hey, how much is this?
Yeah.
How much charging you? Just tell me once. I just need to know.
He will only tell once I send him the files
Okay.
and stuff.
I would also like to know because it's quite expensive sometimes.
JP, like if you live in India, you know like how much he will charge for those components to solder.
I don't know.
I don't. I also have no idea.
No, but you can also look. JLPCB does it for free, yeah. So if you
Yeah,
do a
if
one layer board,
No, I was thinking to do it 2 layers. 1 layer does not look that appealing.
you can do a 2-layer board, but if you just have your components on one layer, then JLPCB will populate for free for you. You just pay for the components.
Okay, so I have to just pay for the components. The PCB, the board will be given them. Okay, so that's the challenge. Okay.
So you can have 2 layers with tracks on top and bottom, but just have your components on one layer.
Hey JP, I can do one thing. Like
Yeah.
I can help you with that. So I'm ordering my version 2 PCBs for the flight controller like in a week. So if you can finish the project in a week and you give me the Javas, I will order it for you.
Yeah, because you guys can save money on shipment.
Yeah. So basically, like he will, his stuff is very less. So even I can bear like cost. Like there is no issue for me. We can manage that. Like that's
Okay.
issue. Because we have
Open
to
the
pay.
data sheet, Chris.
So it's
I'm
that.
sorry.
Just-
Open the data sheet. You only have a week to finish the project now, so let's go.
Why so?
Kamikaze, I don't know if I need a different voltage regulator. I think it's this capacitor that's the issue. But if if this one that we're looking at now is footprint compatible, I'm going to try this one.
JP, did you
Okay,
saw like
so
how much the voltage it sags? Hey, on the first line, that's it's there.
okay, input. Okay, so this is doable.
Mm-hmm.
And this is also like cheap and short circuit. There's also short circuit protection, so you will be way better with this one.
1 amp. That's
With the,
nice. That's very nice. Okay.
yeah.
Just look at the pinout, Krish. Now I just want you to look something for me.
This one.
Type that name in KiCad. Let's first get the footprint in KiCad. That
I
number.
will just. I will just.
JP is the same footprint like normal 3.3 volt regulators. It's the same.
Do you think the pinning is identical?
Yeah, the pins are like totally
I know the
identical.
footprint, but maybe pin 2 is pin 3 on the other one or not?
No, I don't think this is available.
The
No,
three pins.
delete. Just delete.
Yeah, one side has 3 pins, right?
Yeah, I
So-
understand that, but maybe pin 1 for one is output and pin 2 for the other one's output, or not?
No.
Okay.
The output is only in the two leg side. The output
Okay.
is only like on the two leg side always. One is the NC and another one is the 3.3. Okay, it's there already. Looks like it.
You can just read, Chris. So it's 200 milliamps. So it doesn't really matter. I think for these, all the footprints will be identical. It's just the information.
Yeah.
Okay, so I can take any of them, right? So this is the thing we are talking.
Yes.
Yeah, just footprint before doing anything. Just need to check the footprint.
Put it next to that one, because if that's identical, I'm going to order this component right now.
Why?
Because I'm going to replace my regulator. Go, zoom in. Zoom in. I can't see. You see what I mean? So it's not the same.
Okay, just a second. So it's not the same because what does that BP do? The BP pin do? What does it do?
That's bypass filter.
This one.
Okay, so see, the fifth pin, which is not on this one, it's just an NC.
The fourth pin, yeah, but now the output is pin 5 and the output is pin 3. So it's not interchangeable.
Can I share the screen?
Yeah, you can.
Yeah.
Chris, you can delete the component on the left-hand side, that one.
This one?
Yes.
Okay, so how do you... wait. How do you take this out? Okay. You can enter...
Just highlight and push delete.
Where is... Okay, delete.
So now look at the datasheet and see how you're going to connect that component.
Okay.
You can directly give it 5 volts.
Sorry?
I can directly give it 5 volts.
Yeah, but we're not going to have a 5 volt
battery
input.
voltage to the enable pin. Direct.
This pin, but we are not providing. But we are not providing 5 volts. We are providing 3.7 volts.
Yeah.
Yeah. No, yeah. So you need to check the minimum.
Are we losing Rajneesh, JP?
Yeah, that's fine. That's not an issue. Just go below and check.
JS, yes, that's correct. So if you've got 2 sides and you order, you can just choose which side you want to populate, and they'll populate one side. So it is free, but you have to buy their components, and they can't outsource components for you. So you can only use components that they have.
Who has the components? GLC.
Yes.
So okay, I will talk to my dealer. I will talk to the global dealer.
It's not dodgy, man.
I mean, he was what he was telling me. You just send us the Gerber files and stuff,
Yeah.
we can do any component.
No,
Give
they
it a name
can,
like
but
yeah.
you can pay for it, eh? Krish, it can be
Yeah.
expensive. Like
I mean,
PCBs
not
are
too expensive. Uh,
no,
can
I
it be?
think I don't know about India, but PCB way, if they populate for you, you are looking about $20 per board.
$20 amounts to almost
As
um yeah, $20 is achieve. I mean, it's cheap for me as well.
Okay, then that's fine. Then you'll be fine with these components. But gel
Yeah.
PCB is even cheaper.
Krish,
Okay. Yeah. Ha. Yes, Rajesh.
I will share an experience.
Wait.
I will just
Wait
share
one
an
second. I will.
experience of a
One
friend.
second. One second. One second. One second.
You're breaking
That's
up,
too much.
Ramesh.
That's too much.
What? Too much what? Yeah, you're
But
breaking up. You're
it will be
speaking like
bad.
a
Like,
robot.
I'm breaking up.
Yes. I'm hearing every fifth word.
That's
Can
India.
supply 500 milliamps. Yes, this one. But kamikaze, just to
Everybody is liking this regulator.
yeah, but just to explain, so this can handle 500 milliamps, right? But my ESP32 doesn't need more than 500 milliamps. The motors do, but my motors get supplied by my battery, so it is not that. But the problem is my battery is taking all my current, everything, and this capacitor can't handle it, so it pulls this down. I'm not too sure if it's to do with my voltage regulator. It can be, but I'll have to have a look.
JP, it may also be happening like um, the voltage regulator might
JP, are
be
you able to
not
hear
like
him?
having enough
Ye-
voltage to.
Yes, I can hear now. Sorry, what did you say, Ranesh? They're breaking up.
I think what might be happening uh, that the regulator does it get hot, the regulator? Does
No,
the
it
regulator
doesn't.
get hot?
No. I think my motors are just taking everything because I've
Just
read
try
about
to
it.
change the regulator once.
Yeah, I can change it, but it's not going to help now with my current footprint.
Yeah,
I have
I
to.
also told
So we'll see.
Kamikaze. Hey, Kamikaze, he also flies drones. Actually,
Yeah, so he
Kamikaze
says I
also
must
flies
look at
drones.
the
I have seen his
A11.
posts on Instagram. Just
Yeah, you're breaking up.
Yeah, I think he's breaking up. Yeah, I can you
again,
just change your network? That works in most cases.
Cool, Chris. So let's put this circuit together then.
Yeah. So we have this component and this. Wow. Hmm. I'm sharing my screen, right? Think. Yeah.
Yes. But I lost my tab now. Okay, what does the data sheet say?
Data sheet says the pins that you wanted to look at the pins. What pins are available?
Yeah, so the enable pin, what voltage does it require to become enabled?
EN pin. Mm, I think it's at the top.
I normally just control F and search for a specific thing.
Oh, okay. So EN voltage. I should search
Yeah, I'll just type in EN.
EN. CF.
There we go. So you were there, back. So you can
This
see
one.
my enable pin minimum is minus 0.326. So you can have your 3.7 volts is fine. So you can directly
Right.
connect your battery to that. So that's no
To
issue.
the regulator.
Yes.
Okay.
So
So
your in is
Maybe
going to be
you
equal.
can
Yeah.
give minus. You can
Sorry?
give minus 0.326 volts to the enable pin.
Yes, that's what it
My
says.
voice is breaking.
Yeah. So Chris, you can connect
Hold
enable pin
so
and
how
the
do
in
you
pin.
so how do you like connect actually? I mean, I think IN and ground will go to the battery, and EN and out will go here, I guess.
No, no. So what a voltage regulator does, it takes your input of a higher voltage and gives you output of a lower voltage. So it's got nothing to do with your microcontroller. This will supply power to your microcontroller. So your out is correct. That's
Also,
3 point.
so by the description, I think a regulator is nothing but a transformer.
Yeah, if you want to see it like that.
Yeah.
It's a bit different, but different
But
technology,
these
but yes.
doesn't I yeah, but these regulators doesn't isolate your circuit.
Yeah, so same idea, but different
Is my
technology.
voice?
Yeah, it's
Right.
breaking. It sounds like a robot. So Krish, so your in and enable can be connected together?
I mean, why do you want it to connect it together?
So your input is your 3.7 volts, right? So I'm going to take my
Yeah.
3.7 volts. I'm going to create a 3.3 volt. But my enable pin tells the chip that it is on or off. So normally you can connect a microcontroller to an enable pin to toggle it. So I either switch it on or I switch it off. But now we
Right.
connect it straight to my 3.7 volts, and I tell it I'm going to be on all the time. So it's never going to be off. So when there's a battery, there will be 3.3. That's why we connect the two together.
Okay.
Does it make sense?
Yeah. Yeah, that makes sense. Right. So, how do you like connect
W
connect the
for
dots?
wire. W for wire.
Okay, so here you have the wire. Okay, so yeah,
And now we
and
need
then
an
you
input. So now,
then
yeah.
now I pull this thing now. Wait. Oh, yeah. What? Wait.
Kamikaze 500 milliamps. What are you doing, Krish?
Wait.
Okay,
I'm trying.
cancel, escape. So push escape.
Yeah.
Now we got to place a power port. So we push P, I think, for power. And now we can type VBAT. You might not have it. Type VBAT. Okay, VBAT, one word. Okay, now. Yeah, you can install symbols, but let's not do that now. Just say backspace. Let's just look what supply we can use. Delete. No, don't use VBAT.
Just make
VBAT
it bad.
is that BAT? BAT? Yeah, use that. And I'll put it on top there. No, close to that wire. It's going to connect to your input.
Okay. No worries.
Escape. Always push escape. So you need to start fresh.
Oh. So putting this wire.
Yes. But try to do it more up. So it's always nice. So rule of thumb is there's no technical reason for this, but the rest of the world does it. Your voltage is always up. Your ground is down. Always.
Okay.
Do you understand what I mean?
Right. I got it. So voltage here, and then do we need a minus battery as well?
The ground.
So the ground, yeah.
GND.
Minus.
No. Don't do it like. Yeah. Yeah, just make it ground, GND.
Don't.
Uh-huh. So I can connect. Yeah.
If you use the negative band, that means have a negative voltage.
Yeah, no, he's not using a negative battery.
Yeah, yeah.
You're breaking
It's
up,
a
eh?
negative battery and ground is
My
different.
voice is
It depends, Chris. So a supply can be
yeah.
negative,
That's
so you can get negative 12, negative 20 volts.
Oh,
It's possible.
it's
But
possible.
I know in high school they told us plus and minus, right? So they told you plus is
Yeah.
the positive side, minus is the ground. So I understand why you're
Yeah.
doing it. But
Mm-hmm.
normally in your design, your ground has to be the same for everything. So your battery ground has to be the same, your microcontroller ground. So the ground has to be together. Later on, you can split grounds and stuff, but don't worry about that now. So just know your
Okay.
ground has to be the same for everything in your design.
Okay.
Okay. And I just connected. It's not connected. They're just
Okay.
floating in
So
the air.
okay. 1 second.
maybe my voice still breaking.
Yes.
Yeah, it's done.
Okay, and then you have an output.
This one.
Hold on, I'll
And
be
where do I connect this?
Just to a 3v3. Bye, JS. This will be my last stream of the year, so I'll see you next year. Have a good New Year's and all that stuff. No, no, no. Where are you going? Where are you going? Go back, Krish. Go back, Krish. You're going too far. You're going too far. Just make a straight line like you did with VBAT.
Uh,
Like you did with VBAT on the left-hand side. Do the same on the right-hand side. Nah, just straight line.
like
Delete.
this.
No, that's not down. Just straight. It needs to look nice. It looks to
Oh, straight like this. Okay. Uh, 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 uh. Okay. Um. I.
great. So just make it go up a bit.
No. 1 second. 1 second. This is.
Up, not down. Up. Voltage always goes up.
No, this thing. No.
Happy
Yeah.
New Year, JS. Just up, up. You don't have to make it so long. Don't have to make it fancy. Yeah, there we go. Just double click and escape. And now you need a 3v3 symbol. So we've got the VBAT on the right hand side. Now we've got a 3v3 on the, we got the VBAT on the left hand side. And now we need 3v3 on the right hand side. So you can place another
Yeah.
power port, P.
This one. Plus.
Yes, that's perfect.
Okay. Done.
Great. So you got the VBAT input, and then it's going to give you 3v3. So what's missing, Jay? Ach, Jay. Krish?
What is missing?
Yes.
We are. We have
There's
to
some
connect to
important
this.
components that every voltage regulator has that's missing
Okay.
in this design.
So
Go look at the
what are
data
they?
sheet. No, go look at the data sheet. So
Yeah.
every single voltage regulator will have these components.
And they are.
Just look at the data sheet, Jay. Ach,
Hey,
Jay.
my voice still breaking.
Yeah, the data sheet is up.
Yeah, but then look for your, because what's going to happen in the future, you're going to want to build something and you're going to have to look at the schematics in the data sheet to be able to build something. So I just want you to get an habit to look at the data sheet, look at typical applications, and then you can start working around that. Because all the chip does is a process, right? So a chip wants to do something for you. So this chip wants to regulate voltage for you. You've got a chip that detects sound for you. You've got a chip that controls LEDs. They all work on the same principles. It's a process. So what are you seeing there? It's a typical application.
1 second. Sorry. Yeah. Typical application of the. Okay, so as in the last data sheet now.
Yes, that's a typical application there. Oh, it's right there.
It was this one. Okay. Yeah. So this is for what? exactly?
That's just how generic looks. So what do you see on the left hand side and what do you see on the right hand side?
So
That you
here
are
it
missing.
is. Oh, okay. 1 second. Here it is only 4 pins, but I have 5 pins here.
Where you still have 4 pins. You have 1 pin that's not connected.
Okay.
There's
Oh, yeah.
5, but pin 4 is not
Oh,
connected.
okay, okay. Okay, so there is something with the numbering.
Mm-hmm.
Yeah. So ground. We need
Guys,
to
I think
connect this
you
to
could
a.
3 amps. So do you see on the left hand side? So every voltage regulator needs decoupling capacitors.
Okay. Decoupling capacitors. So that comes in the input and output. Yeah.
Always, yeah.
Yeah. So I need to search in power again.
No.
Uh,
Now it's a component. So now you push A.
oh, okay. No. This is something else.
No, you can. No, it's not CN. So normally I do cap. No. Okay, so a capacitor has many different roles in a circuit. So it's just one of its roles, a decoupling capacitor. So a capacitor is a capacitor. So search for a cap. There we go. So I normally go cap small because the symbols are nice and small. So spacebar small.
No. Okay.
You can say cap small.
Oh,
There,
this
and I use
one.
that normally. Yeah.
And place it right here.
Yes, and you have to put it to ground.
Oh, in ground here.
You can, or just make another symbol. So decoupling capacitor is always across your voltage and your ground. So like you mentioned earlier, a decoupling capacitor is a capacitor is like a small battery. So it stores charge, right? Are you with me?
Are you talking to Rajneesh or me?
No, to you.
Yeah. So you said every
Yes. But
regulator needs a decoupling capacitor.
yeah, but a capacitor, yeah, so forget about decoupling capacitors. A capacitor is like a small battery, like you mentioned earlier, right? So it can
Yeah.
store charge and discharge. So what a
Right.
decoupling capacitor does is just, let's say you got a 3.7 volt input, and it can be a bad signal, it's an ugly signal, and goes 3.8, 3.6, 3.8, 3.5, right? You don't
Right.
want that on your output. So you put capacitors in parallel, to ground, so it will store a bit of charge. So if VBAT goes for a millisecond down to 3.4, my capacitor will still keep that line at 3.7. Do you understand what I'm trying to
Oh.
say?
Yeah.
So the same on
Definitely.
the output. So I've got a 3 volt 3 line, and I want to keep that line stable. So if there's any dips, any ripple, my capacitors keeps its charge. So when I lose, let's say 3.3 volts, you still have a small charge of the battery. That's why with
Yeah.
your speaker system, that LED goes off only after 2 seconds because the capacitor
Right.
still keeps the charge. So
Right.
that's why we have decoupling capacitors, to make sure the signal or the voltage is smooth.
Okay. So it's like an inverter, basically, sort of.
Yeah, just think about it. It's a small component that keeps a bit of voltage, bit of charge.
Yeah.
So
And
that's why it's actually
like
ground,
keeps
because
the keep, keeps the line stable.
yes, it keeps the voltage stable.
Yeah.
Uh,
So we need one more here as well, and here.
yeah, you can have 2 there or 2, it doesn't matter. Yeah.
Okay.
Kamikaze, I did not try to
Okay.
connect it directly yet. So when I try to go more than 700 milliamps, I'll get brownout. I will connect it tomorrow directly to the power supply and let you know.
So
That's gonna
we are connecting one here and one here
yes.
as well.
No, that's
Oh,
ground.
okay.
But it has to, your capacitor has to be across your voltage and your ground.
Okay.
Hey, Syed, we're not designing, we're helping Krish with a drone application he wants to do with his ESP.
Wait, it was in and out. Okay. Oh, now I get a hang of it. Yeah, definitely.
Okay, so you have to connect your capacitors to ground.
Like, oh, I. Uh, so you connect to ground like this.
You can, yes. So PCB design is a preference.
Yeah. And we are done.
So now you
So
can
this
take
is
your, yeah, but you need to choose values, right? So you don't have a value for your resistor, your capacitors yet.
okay. So we take C1 and C2 here, I guess. So how do you change this?
No, so that is the designators. That is not the value of the capacitor. So to change that, you're going to go Tools, Annotate Schematic,
Tools,
Annotate
annotate.
Schematic.
Yeah,
Should say Annotate, bottom right.
bottom. Okay. Complete. Close, and then we close it.
Annotate, yeah, you
Okay.
can close it.
Oh. So it. Oh, so this is a shortcut.
Yes, yes, you never want to do it manually because there's chance that you do say you can't have two C1s on your board.
Right.
So okay, so that's fine. So the 3v3 on the top right, you need to take to the board on your left hand side on the ESP.
So you connect it directly.
Yes.
Okay. Oh.
But don't do it with the wire.
CP3
Don't do it with
has
the
been so
wire.
it will look like anyhow.
Sorry? Don't do it with the wire, Krish. So copy that symbol, cancel, push escape.
Yeah, escape is done. Then.
No, push escape. There should be no, there we go. Is escape done? You
Yeah,
still,
done.
you still seem to have a like a thing, like a pencil. If you click, what happens?
Oh.
You didn't push escape.
Oh,
There
no.
we go. So highlight 3v3.
So you have to copy this.
Pushy, copy it.
Oh.
There we go. And then you can just take it across. No, don't put it directly. Always have a wire. It makes it look nicer. Bit to the left, bit to the left. So you always want to go out your component and then up.
Okay.
Hey, Sayed, no worries. So next year, I'm going to, unfortunately, only do this live stream once on weekends because I'm starting to work again. But yeah, then you guys can still pop in and I'll help you.
Like so.
Yes, perfect. Now you need to connect the ground to your ESP32 as well.
So we have a ground 3 here. We can connect this.
Copy it, eh?
Can
So
we
you wanna
take?
copy?
Okay. Okay. And we'll paste it somewhere here, and then we will wire this. What?
Yeah, it's fine. Wire, perfect.
Yeah.
Okay. And just check, there might be more grounds on that IC here. So there's ground 2.
Yeah. No. Wait. So yeah. So ground 1 is here, and ground 2 is here.
Yeah, so
26 and
connect them all.
14. Oh, all. Okay. I thought
Yes.
one only.
All grounds always have to be connected.
Okay. And This is fun. Where is the ground here? Hi.
Kamikaze, the voltage regulator doesn't supply power to my motors. It supplies power to my ESP32. My motors are coupled directly to my battery. But the problem is my battery is also supplying of input voltage to my regulator. So all the power is going to the batteries, and I don't have a capacitor strong enough to keep some charge for my input of my regulator. I've got a feeling I can put a 1 amp also with the A17. It's going to do the same thing because of the capacitor. So tomorrow or tonight, I'm going to try and increase the capacitance and see what happens. What I'm also going to try to do is break up the two supplies. So I'm going to supply my ESP32 with a different supplier than my motors and see if that helps as well, just for the concept. But yeah, the 500 milliamps is not going to the motors, it's going to my ESP32 and my MPU 650. Does that make sense?
Yeah. Done.
Yeah, I'm talking to Kamikaze. Sorry, Krish. But
No,
yeah, well done,
never
man.
mind.
Well done.
And okay.
And you're gonna, so there's, yeah, that's fine. That's perfect. Now you need 4 lines for your PWM for your motors.
Right.
So you just have to make
So
sure that you use PWM.
yeah, so it was this article, right? So IO pins, and then you have this P pins, passive pins.
No, that's not that. It's IO pins.
Okay, so IO pins is not necessarily PWM.
No, it will
Wait,
be a normal IO pin. But I think most of them can probably be IO pins. So
speed 32 PWM.
I think they can be all IO pins. You can just check.
Wait.
What does it say?
Yeah, so this is
Do you see any PWM? I struggle to see. I actually think all their pins can be PWM pins.
wait, yeah, see this wavy symbol right here, it is available on everyone,
Yes.
every
Except,
single one of them. So everything is a PWM.
so let's choose the
Nice.
4 then.
Yeah, so we will just go with something standard. Can we choose 29, 30, 31, and 32? Oh no.
You must look at the IO, right? So the right hand side, the red part, is your pin physical pin numbers. So if you look at the legs, 1, 2, 3, 4, that's the red side. The IO35, the IO22 is the Arduino where you program it and you say
Yeah,
pin output 25. You know what I mean?
yeah, so we can put it in IO5, IO17, 16, 14.
Should be fine, yes.
Yeah, so
You must say if something doesn't make sense, eh?
sorry?
You must tell me if something doesn't make sense or I'm not explaining something correctly. You
Okay.
must stop me, okay?
Sure. So what do we connect these to the motors directly?
They
To
will
the
go.
four
They won't go to the motors because the motors need the battery supply,
MOSFETs.
the Mosfets. So this will go
Yeah.
into the gate of the Mosfet.
Okay, so we need to bring the MOSFET symbol first.
Yes. So go to SI2302. No.
S
Sorry. SI2302.
23 no, 230 or O?
23000. Sorry, man.
So
Cheers, Syed.
no,
Thanks for popping by.
you have 2319 and 2371.
Yeah, that's fine. It's at a P channel or N channel. No, we need an N channel. 2, 3. Like, you know the difference between N-channel, P-channel MOSFET?
There is this NPN. No, that is in transistors. NPN and
That's
PNP transistor.
It's
That is
very
different.
close. It's very close. A MOSFET and transistor it's very close to one another. Same principle.
Okay.
So the P MOSFET switches on when you pull it low, and an N-channel MOSFET switches on when you pull it high. So it's like a switch. So your gate has a
Okay, so
threshold.
I can remember it like positive is negative for this and negative is positive.
Yeah, you'll learn
So
about it later.
yeah, I mean just to remember it for now. P
Yeah.
channel and N channel.
But look for N
Okay.
channel. So I've got a SI2302. But just search N channel for now.
One second. Yeah, so you have transistor, this one,
No,
minus,
that's a P channel.
okay, oh,
Okay.
this one.
Take the power MOSFET VNP10 down.
Which one?
VNP1.
PNP.
Yeah, that one. Take that.
And
Let's just to get the symbol now. We can choose the correct component now. And then put 4 of them.
okay. So those four should be in line. Or like,
It can be whatever you want it, but yeah, you must always try to make it look neat, because in a year's time when you're going to come back to it, it needs to make sense what you've done.
it's correct. Okay, so oh, yeah.
I think it's rated enough. I must check. Last time I checked, it was enough.
Sorry.
They're asking questions on the chat.
Oh, okay. So how do you wire this?
How do you wire it? I'll show you now. My MOSFET can handle up to 4 amps, so it's not failing yet. So your gate is pin 1. So the gate is like your enable bit. So you either switch a MOSFET on or off by the gate. So your signals will go to the gate. So connected to the gate.
So, okay, so I will take these 4 pins, right? Yeah, okay. So,
But now, Chris, just go make a line there. Don't connect it like that. It'll make it look ugly. So just make a straight line.
oh, like this.
No, not too far. Not so far. No. Just make a straight line. No, don't connect to anything. Just make a straight line. Not so far. Just no. Don't just go back before the ground.
Okay.
And just straight line. Double click. And now push
Like
escape. Push escape. You're not going to connect it to anything.
Acha, so I don't need to do. So so you're telling me to number this and then do that.
You're going to use labels.
Label, that label thing. Okay, so ouch.
No. Just make a straight line. Don't bend it.
Like
Don't
this.
anything. Just make a straight line. Double click. And
Yeah.
then do the next one. Yes.
Yeah.
And I push L for label. Escape. Always push escape. L for labels. And then you type in M1 for motor 1. M1.
N1. M1. Okay. Okay.
Underscore.
Oh. Okay. How do you get back? Wait. You can't delete or okay.
No, just
Escape.
L,
L,
and now you say M1
M,
underscore
yeah,
PWM. Okay. And I put that on one of the lines that you just created.
this one.
On the line, fully on the line. But not on the line, the whole word over the line.
Oh, okay. Oh, okay.
And then
Okay.
you can copy and paste it on all other 3 lines. Escape, always press escape. There we go. And now you can. Yes, other one. Another one. And now I just change the 1 to 1, 2, 3, 4.
Yeah, so you can, oh, they got out. Yeah, so how do you change the, you go again into label, double click.
Yeah.
Oh, perfect.
Yeah. Now this has to go to the gate of your Mosfet. So the gate is pin 1 of the Mosfet.
Hmm.
So you
So,
make another line there and don't connect wires. So you must connect with your labels. When you have wires connecting all over the place, then it gets very ugly.
okay, got
So
that.
are you looking?
So, sorry, what?
No, that's fine. Just so you're going to make lines at your pin 1, straight lines. So exactly the same you did for your microcontroller, you're going to go do to the
Oh,
gate of your MOSFET.
okay. So, can I do this like downwards?
No, you can, but you need to make it look neat. So give
Okay.
yourself some space. It's an art piece. It's not just connecting it. It needs to look nice
Okay.
someone needs to look at it one day or something. But you can do what you
Uh,
want. I can't stop you. But just think about it in 2 months' time. You want to come back, and then you can look at it. It's like,
I mean
what did I
I'm
do?
comfortable. I'm comfortable doing this because I don't have a lot of space here. I can always do this. I mean, you can. One second. I will delete all these.
Why are you
This
deleting
one.
it?
Then I can put it like down.
You can move it, right?
You can move it.
Yes.
One second. Ouch.
Cancel. Always push escape.
Yeah. And how do you
Now you
move
just
it?
highlight it. Always push escape.
Ouch. Uh, yeah. Oh, so you highlight it and move.
Yes. Yeah,
Oh,
kamikaze. That's exactly that. So if the MOSFET supply battery the power, there'll be smoke. Power to the battery, there'll be smoke. But it might be. My MOSFET might be wrong. I don't know. But I do think its capacitor is just not having enough juice. But it's frustrating because it's so close to taking off and then it stops. I'll show you a video on Discord. You'll just see that it goes. Zoom.
yeah. And can I rotate this to 90 degrees each of them so
You
that I can
can. You can.
because
But you can move it to the right, eh?
okay, huh? So that can be
You can
also
move
done. Okay.
whatever you want. You can make the page also bigger if you want. You can do whatever you want. It's your canvas. It's your empty sheet.
Okay.
But once you start doing it, you'll notice engineers have a certain way of doing things. So MOSFET it can be upside down, but people always keep it like this.
Okay. And I have to just label it now with the
Yes.
wiring.
Yes.
Okay. Ouch. Uh, not too big. Uh, This is on Twitch as well, no?
Sorry?
The stream is on Twitch as well, no?
It's on Twitch, it's on Facebook, it's on YouTube,
It's on Facebook. Wow.
everywhere. It's on the news.
Wow.
It's
No way.
I use a program where I just stream everywhere.
Yeah.
You have about 500 people watching you now, eh? No stress.
No. Oh my god.
No, I'm joking. I'm joking.
No, you can't. You don't. You should
No,
not do that.
there's 4 people watching. There's no 500.
I thought all together 500 were there on Facebook.
No. I'm not that popular. So now you can take the label, or you can copy the label or you write it. So rather copy it because you don't want to make a spelling mistake.
So I can copy this.
Yeah.
Isn't there Control C and Control V on this?
You can just push C and then we'll copy it.
Yeah, I mean, you want it to be there, copied always.
I always copy it because if you make a spelling mistake, it's not linked because the name's linked now, right? So if you make a spelling mistake on the right hand side, it will not be linked.
Okay, and then you go to label and okay.
Hey Liam, what do you mean experience-wise? We actually made a macro keyboard with the STM32. What type of questions do you have? I did order the macro keyboard, so it should come soon. So we'll see. If you have other hectic questions, you're welcome to join our Discord channel. There's very clever PCB engineers on there who might have done it before.
JP, how do you change this labeling again? I mean, of the
Double-click.
corporate thing? Yeah, but it is coming. But it is a new one.
Because you didn't push escape.
Oh,
Always push escape.
okay. Escape is the key to success, I guess.
Yes, always start fresh. Always start fresh.
Done. And then what do you do? Okay, so this is connected and this is connected. And yeah.
Liam, my understanding is that there's some SMTs that have the USB already function into it, but there's other Fs that doesn't, that you first have to JTAG it, and then you can use the USB connection. So just check at the exact same chip, the chip that you're using. So the one we chose didn't have that capability, so we first had to JTAG it. Does that answer your question? Just look at the data sheet.
Wow.
So there's some F versions that can be USB programmed straight away, and there's some that you first have to do the JTAG ISB, and then you can use USB.
Okay, so now a really cool thing happened. I annotated this, and this is now all mixed up.
Doesn't matter. Doesn't matter.
Oh, I mean, it is messed up with the numbering as well. I changed this to 3, and then okay.
Liam, if you want, on Discord, we've got a GitHub where we've done a design with the STM if you want it as reference. We did it together on the stream like this. Cool, Krish.
Then you connect these, I guess.
Okay, so like we spoke about the gate of your MOSFET, you pull it high to switch on, and when you don't want to switch on, you pull it low. So in a scenario like this, we use a resistor. We call it pull-down resistor. Do you know what pull-down and pull-up is?
I have heard about pull up and pull down. I guess it is similar to step up and step down transformer. No, that is a way different.
You want to control your component's default state. So in the MOSFET side, we want the default of the gate to be 0. So we want to pull it to ground. So when I have no signal at the M4 PWM, then it's going to be 0, and we control that 0. Otherwise, it can be floating. So
Okay.
take a resistor on that PWM line and pull it to ground.
So which one is the resistor? 2 or 3?
No, on the pin 1. So push A, get a resistor, and I'll show you.
Oh, okay. Any resistor? No.
I'll say R small. I like to use a small. Liam, I think then you can directly connect it to USB.
This is this one, no?
Yes.
Yeah, and then you paste it here. This is good.
So what you want to do is, you see the M1 PWM?
Yeah.
We want to pull that to ground.
Okay.
So no,
Okay,
that's
so you
right.
connect.
Yes.
Okay, so right here.
Yes.
Is okay.
And the bottom side of the resistor will be ground.
Okay, so first I will copy and then do the rest of them. Like so, and then I will copy this ground symbol.
Yes. Nice. So you understand what it's doing now?
Yeah. Now I can say to my friends that I'm not a noob in electrical engineering.
No, but you need to understand this. You need to understand. So
Yeah.
what will happen to the MOSFET if you don't have this these resistors?
It will not pull it down.
Yeah. So what? So what I'm gonna do is I pull M1 PWM high, and the current will flow from top to bottom. So I remove it, I'll go to 0. Then my MOSFET is like an unknown state. So we have no idea what's happening inside the microcontroller, because this pin is directly coupled to the microcontroller. So we have no idea what's happening in the microcontroller. So it might do funny stuff while writing programs and start putting noise on my signal. And we're saying, no, we want to control the state of that pin. So we make sure that state is 0. Okay.
Okay. So should I annotate these as well? The
Tools
resistors.
annotate. I normally do it at the end, but you can do it whenever you like.
Okay. Yeah. So so you have connected M to like M1 WPM to this, and this is connected to a resistor and a ground. So all of this is in a connection. Okay. And
So
where do you connect? Where do you connect the 2 and 3?
So your bottom your 3 is going to be ground. So connect all 3 to ground.
Okay. So and the 2.
And then at the top, how can I say this now? So this is where you're going to switch on your battery towards your motor. So
Wait, I will just move this thing a bit. Oh no.
rather go left to right. So if you go right to left, you are highlighting everything you touch. If you go left to right, you're highlighting everything that's in the box.
Okay. So
That will
I'll
highlight
be like,
everything you touch. Yes.
oh, that's good. Okay. Yeah. Oh,
Okay. Yeah, it's you're highlighting everything you touch. I'm going to share my screen, and then you can look, and then it's easier to explain what happens next.
yeah, that's totally true.
No, but can you see my screen if I share it?
Yeah, just
Can
yeah,
you see
I
it?
can. Yeah.
So this is what we did now. We've got this PWM signal
Hmm.
down, right? Now we've got our battery, our motor. So our motor's positive is going to our VBAT,
Hmm.
and our V minus is going to ground. So what happens is I switch this on, and my V minus of my battery becomes ground because this is like a switch, and then it turns on. Then I've got a diode just for protection of the motor and the MOSFET.
Okay. Yeah.
You want
Rajnish was mentioning this Schottky diode as well.
yes. Did you watch my YouTube video about the drawing, the first part?
No, I have downloaded it. It's yet to
So
be watched.
I explained this circuit in detail. We'll explain why.
Okay. Okay,
So
I will.
it might be a good thing to
After
watch.
after the stream, I will watch it.
Just watch that one.
Okay, that's on my list then.
So yeah,
Okay,
so you need to
so
choose.
so I need to create something like this.
Yeah, you have to create this because what happens now? Then I start pulsing this. I put it on, off, on, off, on, off, and the faster and slower I put it on, off is the speed of the motor.
Okay.
So I'm literally
So
just switching it on, off, on, off, on, off. You understand?
yeah,
So
definitely.
LED, everything can be dimmed like this. So this is just a PWM. A nice
So
one.
I will do one thing. I will get this Schottky and I will get this battery plus, and then I will connect the rest of the parts.
Yes.
Yeah. So A, and then you go short. So this is this one, no? Right, yeah.
You can share your screen again if you want.
Oh, I thought it was sharing. E. Yep. So this is. Oh, can't we do like this? Like we make one thing and then copy for the rest of the three, and then change
Yes,
the
you can. You can. That's a good idea. And just
yeah.
move
So
that.
we just focus on one and then do the rest as later. No. So short key is here, and then you copy this. Short key is here. Copy. Short key. Copy.
Thanks for the
Okay, so
follow, Feed the Beast. Just make sure about that's the right that one.
yeah, and no, I think I need to do a bit of spacing. This is all cramped
Yeah,
up. Yeah. So and what do you do after this? After making the short key and connecting it, as you said.
Then we can thinking now what you need a accelerometer, or you've got a accelerometer or not?
Yeah, I have that IMU.
Yeah, so then we'll need to have a I2C pin where you can solder the IMU onto it. So we can do that as well.
Nay, I have that integrated IMU. It
Yeah, I
is
understand.
called
MPU 650.
yeah,
But-
MPU 650, right?
Connected with I2C to the ESP32.
Yeah.
So that still needs to be done. I'm just thinking what we're going to miss. You've got a voltage regulator now. And you're going to need places for your motors to be soldered onto or connected to. Right?
Yeah, so I will like the diagram where you have that photo
You
of the
seem
four
tired,
motor.
Krish.
No, no, I'm not tired. I mean, I can. So this is the last stream for this year, no? So you will come back on first or second, I guess.
Yeah, so I'm working again from the 4th. So I'll stream on next Saturday, Sunday again. But I can help you on Discord. So don't worry too much about streaming. So if you've got questions, you can ask on Discord. I'll help you there.
Okay.
So don't worry too much about streaming. I just stream when I'm available. But yeah, I think, and then yeah, so have a look at my YouTube video about the drone, because this is basically what you're doing, and that can help a lot to understand.
Yeah.
And then tomorrow,
So
what time do you have available tomorrow? And then we can chat to see what you've done and stuff.
tomorrow I'm available from your time. I'm available from 11 from your time.
Okay, so maybe we have a chat in the morning on Discord.
Yeah.
And then we can just quickly go through it.
Yeah, so I will do this short key thing by tomorrow, and then I will look into your YouTube video and try to, get a hang of the.
Yeah, I think you should. Yeah.
Yeah, and then I will come on Discord and then I will stream there.
Yes, then we can do it there.
Yeah, definitely. So tomorrow you're coming then?
Yeah, I'm at home tomorrow, but I just can't stream. I'm busy with other stuff, but we can have a quick chat for half an hour or so.
Yeah, definitely. So, okay, then.
Great, Krish. I hope it helped.
Thank you.
Pleasure, man.
So
have a good night. Thank
you. Good night. Bye.
Bye. Smile. You seem so tired.
Yeah.
Bye, Krish. Great. Is there any other questions, guys? Otherwise, I'm going to call it a night, have some supper as well. That was a pretty good stream. Help some people. That's good. That's why we're here. It seems weird. I'm looking myself here, but the camera's there. Anyway, I need a haircut, but all the hairdressers are closed. So this is going to go crazy. Lockdown is fun. Guys, that was a good stream. Thanks for joining. Appreciate it. Like always, just join our Discord so we chat, we help each other. So this is only a small part of what's happening behind the stage and what's happening in Discord, chatting to one another. There's other people helping as well, so it's not just me. Have a fantastic night, guys. Until next time. So this is the last stream of the year. Have a good New Year's. Have a good holidays, wherever you are. And I'll see you guys again live on the 9th of January. Cheers, guys.